API 652 Tank Lining. In this module, you shall learn about lining of above ground storage tank, bottoms, corrosion mechanism, why we need lining, type of lining, application, repair, and safety issues. The common mechanism of tank bottom corrosion include chemical corrosion, which is acidic product cleanup if diluted in the tanks becomes reactive and more corrosive, especially in the acid inlet piping. Concentration cell corrosion will cause pitting and may result in significant localized metal loss. Galvanic cell corrosion, carbon steel coming out of mill have an oxide layer called mill scale, which is cathodic to the base metal, causing pitting corrosion, especially at the heat affected zone. Mill scale can be removed by pickling or blasting. Corrosion caused by sulfate reducing bacteria, SRB. SRB reduces sulfates to sulfide, forming iron sulfide, which is cathodic to the base metal, promoting accelerated pitting corrosion by a galvanic mechanism. Erosion corrosion. Corrosion occurring in presence of abrasives accelerated by agitation, such as the tank mixer. Erosion also dislodges the corroded layer, exposing the uncorroded base metal to corrosion, therefore causing highly localized metal loss in a well-defined pattern. Determination of the need for the tank bottom lining. Bottom plates are normally thinner than annular plates, which are around 0.25 to half an inch, and it is important that they are supported by uniform layer of soil from underneath. The bottom plate is exposed to both internal and external corrosion, and internal lining helps protecting it from corrosion. If the bottom plate is more than 0.1 inch or rate of corrosion is so fast that by next scheduled inspection the bottom plate thickness is expected to be less than the minimum required thickness, then internal lining of the bottom plate may be necessary. Tank internals such as heaters and mixers, as well as irregularities such as rivets and welds, may prevent laying the internal lining or make it difficult to install. Improper support of tank foundation by soil or fillings may cause bottom plate to flex and crack the lining. A properly applied internal bottom lining provides leak prevention by limiting internal corrosion of the steel tank bottom. Cathodic protection can often provide resistance to soil side corrosion, although not all installations are suitable for cathodic protection. Properly applied tank bottom lining may provide 10 to 20 years of service life in a particular product. Type of tank fluid dictates the type of lining that may be used. A lining suitable for one fluid may not be suitable for another product, so change of tank fluid may be considered when choosing the type of bottom lining. Internal linings are divided into two main groups. Thin films, generally made of epoxy resins, 20 mils or less. They are cheaper and easily applied. You can see table 1, thin film tank bottom lining system for their type of services and working temperature range. Thick films, greater than 20 mils, such as glass reinforced lining, are more resistant to mechanical damage than thin film and in fact can provide strength where bottom linings failed locally. Thick film lining also fill in pitting and other irregularities. The disadvantage of thick lining being more costly than thin lining, more difficult and time-consuming to apply, and more vulnerable to bottom flexing and may crack as a result. It may also dissolve into the fluid. Excess primer thickness is a common cause of failure of thick film lining system. cleaning include solvent cleaning and high-pressure water or steam cleaning. Surface preparation is of utmost importance for proper adhesion and longevity of the lining. Generally, abrasive blast cleaning to a white metal finish is required. Abrasive blasting should not be performed if the temperature of the steel surface is less than 5 degrees Fahrenheit or 3 degrees centigrade above the dew point, or if the relative humidity is greater than 80%. Grinding and removal of sharp corners, edges, offsets, and weld spatter, and putting in of extremely rough areas are necessary. Coating is done on part of the shell body, the transition from tank bottom to shell, to prevent cracking of the lining, and it is important. When the tank is put into service and the tank is loaded, the hoop stress on the shell may cause the lining to crack at the transition. Storage tank bottom linings generally cover the entire tank bottom and extends 18 inch to 24 inch of the shell of the tank. This can be a potential exam question. How far do you extend it on the shell from the tank bottom lining? Holiday testing of thick film lining shall be carried out with a high voltage detector. Holiday testing of thin film lining should be performed with a low voltage wet sponge detector. Tank entry shall be as per confined space for entry detailed in API standard 2015. So they might ask, what is the standard for tank entry? It's API 2015. And remember, all API 2000 series are safety. Material safety data sheet concisely inform employees about the materials being used so that they can protect themselves and respond properly for emergency situations. It gives such information as physical properties and hazards that you may encounter, recommended personal protective equipment PPE, such as masks, goggles, gloves, clothing, safe handling, first aid treatment in case of accident. Here you can see the annular plate, which is the surrounding one. This annular plate, because it also connected from here, from the corner to the shell, so it's under a lot of stress. So that's why they take it. This is the most critical part of the tank bottom, called annular plate. And because there is a hinging action or momentum here due to connection to shell. And then you have the bottom plate here. Here you can see a tank bottom be ready to be blasted. And here it's all painted, including the columns, as you can see here. Tank. Summary. This recommended practice describes the procedures and practices for achieving effective corrosion control in above-ground storage tank by application of tank bottom linings to existing and to new storage tanks. This recommended practice also provides information and specific guidance for tanks in hydrocarbon service. Some of the practices may be also applicable for other services. Please note that this RP does not designate a specific bottom lining for all situations because of the wide variety of service environments. And this recommended practice is a guide only, and detailed lining specifications are not included. There is nothing on reference publication that you need to remember or refer to during open book, or remember during closed book. Definitions. Above ground storage tank. Stationary container, usually cylindrical in shape, consisting of a metallic roof, shell, bottom, and supporting structure, where more than 90% of the tank volume is above surface grade. So this physical characteristic of 90% of tank bottom above Surface grade could be a potential exam question. Amine, an organic compound having amino functional groups which provides chemical reactivity and utility as a curative for epoxy and other resins. Anchor pattern, surface profile or roughness. Anode, the electrode of an electrochemical cell at which oxidation, corrosion occurs. Electrons flow away from the anode in the external circuit. Corrosion usually occurs and metal ions enter the solution as the anode. This is antonym to cathode. Lining, a coating bonded to the internal surface of tank to serve as a barrier to corrosion by a contained fluid. Mil, 1,000 of an inch, 0.001 inch. Milliscale, an oxide layer formed on steel during hot forming operation. The appearance is sleek, smooth, shiny surface area. Resin, a natural or synthetic substance that may be used as a binder in coatings. So resin is a binder. The common mechanism of internal storage tank bottom corrosion include chemical corrosion, concentration cell corrosion, galvanic cell corrosion, corrosion caused by sulfate-reducing bacteria, erosion corrosion. These apply only if there are no accelerating mechanism present. Example, water collection on tank bottoms may contain salt and sediment that settles out on bottom plates. The chlorides and other soluble salts may provide a strong electrolyte which can promote corrosion. Chemical corrosion, normally seen in environmental and product cleanup tanks. Concentrated acids added to water with heat to break emulsion of oil and water. It works like a detergent or soap, becomes diluted acid, which is much more corrosive than the stronger acid. Remember that the more water added to the acid, the lean acid or less stronger acid is actually more corrosive because there would be more reaction involved here, chemical reaction. Chemical attack also occurs in caustic, sulfuric acid, ballast water, and water neutralization services. Concentration cell corrosion occurs in lower oxygen concentration areas, surface deposits, milliscale, or crevice, recognized as pitting or in a significant localized metal loss area. Galvanic cell corrosion, formation of a bimetallic corrosion coupled due to presence of an electrolyte, dissolved oxygen. The common locations for occurrences are breaks in milliscale, HAZ, heat affected zone adjacent to wells, also noted by significant localized metal loss. Corrosion caused by sulfate reducing bacteria, phenomena recognized but not understood, usually negligible, occasionally service, thought to be associated with concentrated cell corrosion due to deposits forming a barrier to the diffusion of dissolved oxygen. Erosion corrosion normally occurs in mixing tanks where soil particles or a small aggregate are present and movement occurs. For example, wastewater treating or mixing adjacent to mixers in crude tanks. The movement of aggregate causes abrasive attack, normally seen as a well-defined loss pattern. Determination of need for tank bottom linings. Tank bottom normally fabricated from carbon steel plate sections, typically a 1/4 inch, 6 mm thick. Annular floor plate rings may be thicker, up to 1/2 inch, 12 mm. Sketch plates under shell of 5 by 16 inch plate may often be found in older tanks. The need for an internal tank bottom lining is generally based upon one or more of the following: corrosion prevention, tank design, tank history, environmental consideration, flexibility for service change, Offset conditions, federal, state, or local regulations. Lining for corrosion prevention. Proper selection and application of bottom linings can prevent internal bottom corrosion. If the tank bottom requirements indicate that a thickness of T of 0.1 inch exists, or it will be reduced to below 0.1 inch prior to the next scheduled turnaround, then the recommendation for applying a lining should be strongly considered. Design considerations and tank internal. Design or fabrication details that would jeopardize the integrity or limit the life expectancy or effectiveness may exist. Example, steam coils limit accessibility for surface preparation. The resulting thermal effects may cause localized failure by blistering or cracking. Tank history. Consider corrosion history when determining the need for lining. Consider history of other tanks in similar service. Some important considerations are where the corrosion problem is happening: product site, soil site, outer periphery, etc. How often is corrosion proceeding? Has there been a significant change in corrosion rate? What type of corrosion is occurring? Has true bottom penetration occurred, or through the thickness at the bottom? Tank foundation. Inadequate foundation can cause tank settlement. Bottom flexing may occur, causing the internal lining to fail by cracking. Method of construction. Irregular surfaces such as rivets, butt straps, and skip welding are difficult to cover and protect with a lining. Older tank lining application may be complicated because of presence of chemical contaminants. Column bases and roof legs support pads may present application problems. If a prior liner is present and a portion is to be salvaged and reused, the new liner application and material must be compatible. Previous repair. Prior mechanical repair addition must be considered, such as are there old shape patches to cover, support angles to seal, back welded or hot taps that will require special crevice sealing solutions. Prior storage. A special cleaning technique or degree of cleaning required must be considered when evaluating which type of coating is most cost effective. Most major material suppliers have data and technical expertise that can be requested. The data should be free. The technical help will add to cost. Environmental considerations. Properly applied internal linings reduce the chance of external environmental contamination. Cathodic protection also usually reduces underside bottom loss. Location. When considering the need for an internal lining, always consider the potential for groundwater contamination in hydrogeologically sensitive areas, proximity to populated areas or public road, proximity to river, lake, parks, or scenic areas, presence, location of containment dikes, flexibility for service change. Changes in service may drastically affect the performance of existing liners. If swing service is expected of the tank involved, then all potential services and their compatibility with internal lining being considered must be carefully and fully evaluated. Remember, tank lining do not offer universal resistance. Product makeup varies, therefore properties of the lining must vary. Again, technical assistance from the liner supplier can be of great value. Offset conditions. Don't forget the product, the impact involved. Consult customer as to potential for occurrence. Tank bottom lining selection. Tank bottom lining can generally be divided into two classes: thin film 20 mil or less, thick film greater than 20 mils. Linings are installed at tank erection or after some period of service. Generally, thin film is applied when some minimal corrosion has occurred. Other liner discussion includes thin film types, frequently based on epoxy or epoxy copolymer resins. You can see the table 1, lining system for generic types and their suitability for various services. And please note that all linings that are employed to protect tank bottoms must be resistant to water. Advantage and disadvantage of thin film line. Advantages: new plate provides a smooth surface that can easily be made ready for coating application, lower cost due to ease of application. Disadvantage is corrosion creates a rough, pitted surface that's difficult to completely coat and protect. Thick film types commonly reinforced with glass flake, chopped glass fibers, glass mat, glass cloth, or organic fibers. Generic types and where used is in table 2. Specific notes relative to thick film types: all applied over a white or near white abrasive blast. Primer frequently required. Dependent open thickness required. Multiple coats needed. Resin-rich top coat required. Polyesters require wax addition to ensure timely cure. Check with the manufacturer for specifics such as chemical immersion, elevated temperature tolerance, limitation in specific products, etc. Advantages are for thick film: less susceptible to mechanical damage, provides additional strength to breach over small bottom perforations, not as sensitive to pitting and other surface irregularities during installation, less need for removal of sharp corners, edges, offsets, and well spatter. And disadvantages of thick film types are: require more time and effort to apply, more expensive, makes future inspections more difficult. Design of storage tank bottom linings. Normal data or knowledge required. Lining should extend 18 to 24 inch up the shell. Transition area from horizontal to shell vertical is a common failure area. Proper support, especially with thick films, are critical in this area. With thin film types, desired film thickness normally requires 2 to 3 coats. Thick film range from 1 to 4 coats. New tanks or where only internal loss has occurred may require 35 to 55 mils. Older bottoms corroded on both sides may require 80 to 120 mils, usually reinforced. More specific data is white. It should be SSPC SP5 or NACE 1, or a near white SSPC SP10 or NACE 2. Abrasive blast cleaner. Anchor pattern. Surface roughness required is generally between 1.5 and 4 mils, depending on lining selection. Exceptional circumstances affecting selection is: be sure to take into consideration corrosion history or corrosion potential. Elevated temperature above 160 degrees Fahrenheit is critical. Product purity. Thin films may be sufficient. Liner may contaminate product. Surface preparation. Surface preparation is a critical part of lining operation. Surface preparation is performed to provide the appropriate combination of surface cleanliness, surface profile, or anchor profile required to establish good chemical and mechanical adhesion of the coating resin to the substrate, which is steel. Inadequate surface preparation is a major cause of lining failure. However, a well-prepared surface becomes meaningless if all of the abrasive material, such as sand, is not removed prior to primer liner application. In such event, a lack of adhesion, future peeling, or desponding failure can be expected. Continuous immersion presents a severe exposure. SP5 or NACE 1, white metal, or SP10 or NACE 2, near white, is often specified as the minimum degree of surface cleanliness. Pre-cleaning. Before blasting, all contaminants must be removed. Solvent cleaning. SSPC SP1, high pressure water or steam cleaning should be considered. Fresh water wash after solvent cleaning may be required to remove soluble salts and cleaning chemicals. Bottom repair, weld preparation. Most common repair of perforations is welded steel patches. Another repair method is to apply epoxy over the bottom perforation prior to thick film reinforced lining being installed. And as a safety note, weld repair may be disallowed if tank pad has been contaminated with flammable materials. Remove sharp edges, corners, and protrusion. Chipping or power grinding is most common removal method. Abrasive blasting. Do not blast when steel temperature is less than 5 degrees Fahrenheit, 3 degrees centigrade above the dew point, or if the relative humidity is greater than 80%. In particularly humid areas such as coastal regions, potential solutions might be selective timing, which may influence work schedules, or perhaps the use of forced hot air injection. Liner application must be conducted when surface condition is appropriate. Delay between blast and application will produce poor results. When in doubt, restore surface preparation to the necessary degree. Surface profile or anchor pattern. Match profile to accommodate selected liner. Refer to material manufacturer's recommendation. Typical anchor pattern is 1.5 to 4 mils. This generally increases with liner application. Thickness. Types and quality of abrasive is covered in 7.6. Lining application. 8. Avoid desponding or delamination by following manufacturer's recommendation. Stick to time interval between coats recommended by owners. A specification or manufacturer, always follow the manufacturer's specification. That is in every project. SSPC SP1 is a dependable procedure to follow. Establish and adhere to recommended drying period. Customers often get impatient. SSPC PA1 and NACE 6F164 is a good painting practice. Establish and adhere to proper mixing practices. If conflicts arise between owner user, liner applicator, or material manufacturer over any aspect of the job, resolve them prior to beginning the project. Consider restraints imposed by steel temperature and relative humidity. Insufficient field thickness will not provide adequate coverage protection. Excessive thickness can compromise adhesion and integrity. Thicker is not always better. Lining failure is attributed to improper preparation, improper application, inadequate curing. Adhesion and film integrity depend upon above listed items. That means improper application, inadequate curing, and improper preparation. Proper curing condition may be aided by forced curing, circulating warm, dehumidified, or dry air. The lining, if applied satisfactorily, would normally last 10 to 20 years. This can be a potential exam question. If a good lining applied, what would be you expect from the life of it? Inspection. Items 9.1 general through 9.324 discontinuities list some qualifications, parameters, and procedures to assist or guide in the area of inspection. Without going into detail, some or all of the following should provide guidelines or assistance. Coating inspector shall be NACE certified. Recommended inspection parameters. Lining exceeding 20 mil shall be holiday tested with a high voltage detector. Lining less than 20 mil should be tested with a low voltage Metasploit detector. So this can be also a potential exam question. For less than 20 mil, which one you use, high, low voltage, or medium voltage, whatever? So it's always low voltage, or the other way, for a lining, thick lining, or over 20 mils, which voltage would use is high voltage. Repair of tank bottoms. Properly selected applied liners should provide service life of 10 to 20 years. Remember this 10 to 20 year service life. Any bottom mechanical repair should be completed prior to any liner installation or repair. Before deciding how to make a lining failure repair, the cause or extent should be established by visual inspection and a review of operating history. Attempt to determine if failure was due to mechanical damage, environmental attack, or improperly installed. Coat repair for localized failures, blisters, pinholes, or mechanical damage. Top coating for more extensive failure, but where adhesion and integrity is still good. Make sure top coat is compatible with the existing liner. Complete replacement when existing liner is beyond repair. There are some safety measures. Permits for tank entry and hot work should be issued and enforced. Follow guidelines for issuing permits and preparing a tank for confined space entry as detailed in publication API 2015. So API 2015 safety publication, that might be a potential exam question. Surface preparation and lining application. Use respiratory equipment and protective clothing as found in OSHA standard, SSPCPA3, NACE, any relevant federal or state regulation as required on tank entry permit. Manufacturer safety data sheet indicates the chemical makeup that can present health hazards to personnel. MSDS inform about materials so they can you can protect yourself and how to respond properly to emergency situation. Purpose of MSDS is to inform personnel of a material's physical properties, which make it hazardous to handle. Type of personal protective equipment needed, first aid treatment necessary if exposed, safe handling under normal condition and during emergencies such as fires and spills, appropriate response to accidents. We'll have some question here that you can solve. Please go through it. We have also explained these questions. So for example, which of the following pertains to establishes the dew point? And it is C, the temperature at which the moisture condenses from the atmosphere, and that's the definition of dew points. Or indicate the most correct definition for a holiday. Holiday means a hole or a discontinuity. Or this is again benzene, toluene, and xylene are common examples as aromatic solvents. Highly unlikely that this question would come. Mill scale and an oxide layer formed on steel during hot forming operation, and it's more a noble material considered the base metal or the steel itself, and it turns into a and it causes the base metal to corrode actually, so it should be removed. 5 common mechanism normally associated with internal tank bottom correction. At least 3 of the 5 causes below. Match the following SSPC surface preparation to the metal finish specification. So it's same as that. So white metal finish is SSPC SP5 or NACE 1, and near white is SP10. But it might come to you, unfortunately, you need to remember what is SSPC SP5 or NACE 1 stands for, what is SP10 stands for, and so forth. Select the general rule normally followed relative to liner application versus temperature and humidity. So 5 degree above dew point with relative humidity below 80%. This might be a potential question. What is the typical range required on anchor pattern? So 1.5 to 4 mils. This can be a typical question prior to liner application. Natural or synthetic substance that may be used as a binder in coating, it's resin. So definition of resin. When considering the need for internal lining selection, make selection from below as some of the most important. where is corrosion occurring, how fast is it proceeding, have there been significant corrosion rate changes, what type of corrosion is occurring, have bottom perforations occurred, and it's all of the above actually. Thank you.